Let's talk about diffusion models, the idea behind a lot of today's AI image generators. We'll keep it simple. How does a computer turn pure random noise into a brand new picture? Here's a puzzle. How can a computer dream up a photo of a person who has never existed, a face it has never seen, that isn't a copy of anything? It sounds like magic. It isn't. It's a surprisingly simple trick. Take a good look at these faces. Not one of these people is real. Every single one was conjured up by a diffusion model, starting from nothing but random static. By the end of this video, you'll understand exactly how. The whole trick comes in two halves. First, we deliberately wreck a real photo by burying it in noise. Then, we teach a computer to do the reverse, to unwreck it. That second half is where the magic lives. Wrecking a photo is the easy part. Start with a clear picture. Sprinkle in a tiny bit of random static, then a tiny bit more. Keep going, say, 1,000 little steps, and eventually the picture is gone. All that's left is pure TV snow. Here's that journey in one picture. On the far right is a real photo. As you move left, more and more noise piles on until on the far left it's complete static. The bottom arrow is the easy direction, adding noise. The top arrow, going back, is the hard one we have to learn. If you're curious, here's the actual rule for adding one speck of noise. Don't let the symbols scare you. It says something simple. Shrink the current picture just a little and mix in a little fresh random static. That's the entire forward step, written in math. Now anybody can add noise. It takes no intelligence at all. The interesting question is the reverse. If I hand you a noisy mess, can you take away a little of the noise and get a slightly cleaner picture back? That's genuinely hard. So we train a neural network to do exactly that one job. Look at a noisy picture and undo a single step of the noise. Do that step over and over, and you can walk all the way back from static to a clean image. And teaching it is wonderfully simple because we cheated. We made the noise ourselves, so we know exactly what was added. The recipe: take a real photo, add a known amount of noise, ask the network to guess that noise, and gently correct it when it's wrong. Repeat millions of times. One neat shortcut makes this fast. Instead of adding noise one tiny step at a time, this formula lets you jump straight to any noise level in a single leap. So during training, you can instantly dial up exactly as much messiness as you want. And here's the goal the network is actually trained on. It looks dense, but stripped of the notation it says one thing: look at the noisy picture and guess the noise. The better the guess, the smaller this score. The entire training target is predict the noise. Now for the punchline. If the network can look at a noisy picture and tell you exactly what noise is in it, then it also knows how to remove it. Just subtract the noise it guessed. Guessing the noise and cleaning the picture are the same skill. So how do we make a brand new picture? We don't start from a photo at all. We start from pure random static and ask the trained network to clean it up, a little at a time, around 1,000 times, until a clear image emerges. And because the starting static is different every time, you get a different picture every time. A face, or a scene that nobody ever photographed, assembled purely out of the network's sense of what real pictures look like. It can do more than copy faces, too. Because the noise is a kind of dial, you can blend two images by mixing them in their noisy middle. Watch one face smoothly morph into another, with believable faces the whole way across. And this simple recipe works remarkably well. On a standard image benchmark, this paper set a new record for sample quality, better than any method at the time, using 1,000 small denoising steps. Why does this matter? Because this exact idea, wreck a picture with noise, then learn to undo it, is the engine inside the modern text-to-image tools you've probably seen. They're all, at heart, very good noise removers. So the whole magic boils down to 3 plain steps. Wreck a photo with noise, train a network to undo one step, then run it backwards from pure static and a brand new picture appears. That's diffusion. No magic, just adding noise, learning to take it away, and running the clock in reverse. From pure static to a picture that never existed.